Good afternoon, guys. I just wanted to touch base with you to share this video focusing on the try-except logic. In lab activity number 7, you're going to be using the try-except logic in a different way than you've been used to. So I thought I'd put this short video together to try to show you how it's going to be used. And I thought I would start off with something that you're already familiar with, and that is trying to find out if a value, a piece of data that's been requested by Python using an input function is really a numerical value, or if somebody typed in a string. Okay, so if you look at the screen, I've got a number of variables that are declared, just a few variables at the top. And I start the program by requesting a couple of numerical values, enter value 1, enter another value. But the strategy for try-except logic is always the same. You ask the user for a value, and if you recall from previous lectures, the input function in Python, the default data type is string. So historically, what we've done prior to doing error checking, we put the int typecast operator or the float typecast operator prior to the input function so that you can convert the value or convert the string to an integer before it's assigned to the variable on the left-hand side of the assignment operator. You've been doing this since the beginning of class, just about plus or minus a couple of days. So the strategy that's used for try-except logic, and I've mentioned this a number of times on your code, the try portion of the try-except logic, you basically do one task at a time. By doing one task, you basically guarantee that the try-except logic is going to find a single error. If you put too many logical steps in the try block, you reduce the probability of catching or trapping the error. Okay, so in this particular case, what I'm doing is I'm doing a try-except block where what I attempt to do is ask the user for a numerical value. Because I'm using the input function, which is pulling the data in as a string, I'm assigning it to a variable called value1 string. In a previous video, I said that there's nothing special about the str suffix in the variable. It's just a cognitive trigger that basically says that anytime you see that variable in your program, that variable is holding a string. It's just a cognitive thing. It's not a syntactical thing with Python. Okay? So I have it assigned to a variable called value1 string, but I need it for a computation. If you notice down here at line 34, I'm going to be adding the two values together. So if somebody put in the word computer when you said enter value 1, you can't do a mathematical computation on a string. Okay? That's what the point of the try-except logic is. So in this case, from 14 to line 21, what I'm doing is in a loop, I'm going to stay consistently in a loop. I'm going to try to typecast whatever's sitting in value1 string as an integer. If it is a numerical value, it'll work, and it'll assign the numerical value or the numerical equivalent of the string into the variable value1. If it's not, however, Python will throw what's referred to as a value error exception. That's basically telling the outside world there's a problem. You attempted to convert a non-convertible data component into an integer. And if that happens, what we want to do, we don't want the program to crash. What we want to do is we want to tell the user they entered incorrect data and to please re-enter it. Now, a couple of things that I want you to take a look at. Notice that how we got the data originally is exactly how we're going to be repeating it in the except block. Those match, and that'll be the case just about every single time. Okay, it makes it just nice and convenient. You can copy and paste it. So the first thing that I'm going to do if I have an error, I'm going to print to the user, you entered incorrect data, please re-enter, so they know exactly why you're asking them again for the first, in this case, value 1. Then I tell it to pull value 1. Notice I'm not converting it to an integer here. That's going to be occurring once the loop continues. So once I complete the value error block. We loop around. It's still while true. True is always going to be true. So we come back in and attempt to do the try again, which we try to convert the data in value one string as an integer. If it works, great. If it doesn't, we're going to continue looping forever. Okay, so you notice that I have two tryExcept blocks, one for value one, one for value two. Starting in lab activity number 8, you're going to be creating functions or customized functions that do one specific task. One of your functions that you're going to be writing is the ability to write a value checking function. We did that in the video from yesterday, July 4th, so you can take a look at that online. But we'll talk more about that when we get into lab activity 8. So this should be review, all right? Once you verify that the data is entered correctly, we go ahead and ask the user for value 2. We check to make sure it's okay. Once we get to line 34, we know with absolute certainty that value 1 and value 2 are holding numerical values. And the rest is just, you've seen this before 1,000 times with the output function print. So I'm going to go ahead and run this, and so you can see this thing working. And so when I run the code, I'm going to bring this output window opened up a little bit. The program is running and asking me for value 1. So I'm going to deliberately put an error in, and I'm going to type in computer, and the system is trapping it using the except block because Python came back and said, I can't convert computer to a number. It's not a number. So it throws an error. And so that error is processed in the except block of the first. Let me scroll up a little bit. In the first tryExcept block. And we're right now executing line 19 because it's asking for enter value 1. I'm going to put in CS151. That too cannot be processed into or converted into a number. You finally get it, and I'm going to type in the number 5, and we're moving on to the next piece. So now we're currently sitting at line 23, enter another value. The tryExcept logic is working in both cases. So I'm going to go ahead and scroll down. It's just a mimic. So I'm just going to put a numerical value in here. So I'm going to put in number 7. So technically, if this is working using test case data, if I were to say value 1 equals 5, value 2 is equal to 7, the output should be 12. Okay, so when I press the enter key, it outputs. Now, if you look at it, it's not exactly accurate because it says the sum of 5 and 7 is 12. It looks like we need another space. I'm going to go ahead and put another space in there. Notice at the end of the output line, I have the sep equals quote, quote, or sep equals null, which means don't add a space because every time Python sees the presence of a comma between the individual parameters in the print function, it's going to put a space. So let me run this again really quickly with no errors. 4, 7, sum of 4 and 7 is 11. Great, it works. Okay, so this is just a review. What I want to do now is let me close this output window, and I'm going to put something in here. This is going to be the new piece, which allows us to go ahead and check for using tryExcept logic when dealing with files. All right. I mentioned in some of your feedback on your algorithms, some of you were making reference to, commenting on, doing those kinds of things with tryExcept, but you've been brainwashed into thinking that you're going to use the same value error exception, and you can't. As a matter of fact, if you do the tryExcept logic with value error when checking for files, you'll never be able to trap what happens if you have a bad file because value error is not the exception that's going to happen. Instead, I'm going to paste a block of code in here. You see how fast I type? So in this particular case, what I'm doing is I am doing, if you notice there's a similarity, I ask for data, and then if there's a problem, I ask the same thing. So in this case, what I'm doing is I'm asking the user for the name of the file that contains all the data. Now, I created a data file. If you take a look at the left-hand side screen here, you'll notice a file called data.txt. Now, that's a file that exists. It's got some data in it. As a matter of fact, if I double-click in it and open it in PyCharm, you'll notice it is a file that has a 1, a comma, and a 2, a 4, a comma, and a 5. These are actual data values. But the creation of a data file is not the topic of discussion here. We're talking about how to use tryExcept logic with data files or any type of file. So here we go. In line 39, I asked the user, what is the name of the file that contains the data? Well, in our case, it's called data.txt. I'm using my tryExcept logic starting at line 41. I'm in a loop, just like I did before. I have my try reference, just like I had before. The only difference is that I'm going to notice that I'm actually using the variable file name. And I'm going to try to put that file name as one of the parameters in the open syntax in Python. Now, yesterday we went over an example of actually opening up a data file. And the way that you read data from a data file, it's multiple steps. First, you open the data file, then you use the data file, and then you must close the data file. That's the last thing that you do. So at line 43, I'm attempting to open the data file. And you may be saying, what data file? He hasn't put one in yet. Well, you're right, I haven't, because I haven't executed. But the data file is going to be held in a variable called file name. Notice that file name and file name match. So what's going to happen is when Python attempts to execute this line of code at line 43, it's going to replace what the user typed in as far as the data file name and place it in this location. Notice that it's opening the file up as a read file. Now, it's a possibility that the person may have typed the information so fast that the file name doesn't exist. Now notice that the name of the file that I'm going to be looking at is data.txt. Data is the file name. txt or text is the file extension. Together, the file name and extension make up the complete file. Sometimes people don't put the information in completely. Sometimes they type it incorrectly. Sometimes they forget to type the file extension. There's a whole host of reasons why someone might have a problem with entering a file name. The way that Python is going to process a file that has a problem with the file name is it has a brand new type of extension. It's called the file not found error exception. Okay? I think I said extension before, I meant exception. So instead of a value error, Python is going to be using something called a file not found error. So if you tell it to run the program and you tell it, here's the file. Let's say instead of typing in data.txt, I type in data2.txt. Now, one of the things that I mentioned in the feedback and one of the emails, it is critically important that wherever your Python source code file is, your data file must also exist. So wherever you put your source code file, make sure your data file that I gave you for lab activity number 7, those files exist in that folder as well. Okay? So this is saying if a file not found error exception is raised by Python, do the following. And you say, what does do the following mean? Anything in the indented block is going to be executed. What the system is going to say is, the data file you requested to be opened does not exist. Please re-enter complete file with extension. Then it's going to attempt to ask the user for the input file again. Now notice that line 46 and line 39 match. You want to try to be consistent in how you ask questions of the user. It reduces ambiguity, it reduces confusion. So basically what you're going to do is say, give me the file name and the file extension, just like I did before. Python will then loop and try to open up the file that is going to be included in the variable file name. If it works, it will break out of the loop, and I have a couple of output statements here that we're going to try to run, okay? So we know that the top block of code works. So what I'm going to do, if you don't mind, is I'm going to highlight all of my code that is working, because I really don't need to go over it again. And just so you know what I'm about to do is, you know, sometimes you're listening to me and you're saying, wait, how did he do that? I highlighted all of my code. I'm running on a PC. I'm holding the control key down. I think you can do the same thing if you're running a Mac, only holding the command key down. And I'm going to hit the / key. The / key on the PC is the key to the left-hand side of the right shift key. It's the key that has a question mark on it and the slash. All right. Now, if you notice when you do that, it converts all executable code to a comment. So that I'm going to focus on the block of code from line 39 to 52. Okay. So let's see if it works. So I'm going to go ahead and choose run the files, and here we go. Now, the name of the data file that I want to see if it even exists is data.txt. But just to try the tryExcept logic out, let me scroll down so you can see the tryExcept logic. Right now it's at line 39, and since it's an input function, it's waiting for me to enter data. So I'm going to put data2.txt, and when I press the enter key, the except block is executing now because a file not found error exception was returned by Python to say that file data2.txt, it's not available. So I wrote the code to say the data file you request to be opened does not exist. Please re-enter. Complete file with extension. So it's actually asking me now, please enter the data file to read. It says file name .extension. You can do something a little bit different if you want. Let me try something crazy. I'll do that. Same problem. Data tree.csv. Same problem. Those files do not exist. However, if I type in the actual data file, data.txt, what's going to happen is that Python will attempt to open up data.txt. Notice that data.txt does exist in this folder, and it's going to open it up as a read. Once that happens, no file not found error exception will be raised. Therefore, we'll break and then go on to line 51 and 52. So let me press the enter key, and you'll see what it's doing. In line 51, all I did was say, the valid data file name is, and I just basically match file name with file name. So it output data.txt. The object name associated with data.txt, in yesterday's video, I shared with you that Python doesn't like to work directly with files, the file names themselves. It likes to work with something called an object. And that's how you deal with data in files, is through their object name. So what it's basically telling me is the object name associated with data.txt is, this is specific information that Python needs to actually open the file and then allow you the ability to extract data, like by line, by character, whatever you need to do. And we talked about this yesterday. But we really didn't focus on dealing with the tryExcept logic related to if you put the wrong file in. So I wanted to go over that today with you to make sure you understood how the tryExcept logic works. Obviously, your information is going to be looking a little bit different, but I did want to at least go over this with you so you have a better understanding of what tryExcept logic is all about.